Hey guys, welcome to question FM298 of the Further Maths Fortify study guide. This question reads, a construction company is building a new school. The project involves 14 activities labelled from A to N. The directed network below shows these activities and their completion times in weeks, and then we're given the directed network that you see here, minus these strikes that I've just put in, so that when we put in our earliest starting times and latest starting times, we'll have a spot for them. Question A says, determine the earliest starting time for activity K. Looking at some of the other questions that follow question A, so B and C and D, we can quickly see that it's going to be helpful for us to do a forward and backward scan of this directed network. It's going to make answering these questions a lot easier. So we'll start with one of those and then we'll work back from there. So A is going to have an earliest starting time of 0. It takes 13 days, which means C and D are both going to have earliest starting times of 13. 13 add 5 gives H an earliest starting time of 18. And 13 add 8 gives I an earliest starting time of 21. Now for L, we're going to be comparing two starting times. So we've got H, which is taking 11 days on top of our 18, giving us an early starting time of 29. And we've got I, which starts on day 21, taking 7 days, gives us an early starting time of 28. So we're going to take the larger of the two. We've got an early starting time here now of 29, which means from L to completion should take 36 days. B, earliest starting time of 0. E is going to have an earliest starting time of 6 as well as F, because of course B will take 6 days. From here, 6 on and our 9 for activity E is going to give J and G both starting times of, earliest starting time, of 15 weeks. From here, we're going to compare for the earliest starting time of K. We're either looking at earliest starting time of 6 and activity F having 8 days of duration. So either an earliest starting time of 14 weeks, or we're looking at G here, which will be complete by week 16. So picking the larger of the two again, we have an earliest starting time of 16 here. M will have an earliest starting time of 15, add the 7, 22. And now earliest starting time for activity N is either going to be 29 coming off of N, or it's going to be 28 coming out of K. So looking at this, we can say that the earliest starting time for N will be 29, and add that 8 days gives us an earliest completion time of 37 weeks. So that 37 has already been put in for us. We're told a little bit later, just above question B, that the minimum completion time for the school is 37 weeks. So we can be somewhat sure that we've got our forward scan done correctly when it lines up with that. Now for our backward scan, so 8 coming back from 37 brings us back down to 29. 7 back from 29 brings us back to 22. And 12 back from 29 takes us down to 17. Here for activity J, minusing 7 from our 22 lands us back at 15. Moving backwards from activity K, 1 back from 17 is going to land us with a latest starting time of 16. And 8 back from 17 is going to land us with a latest starting time of 9. Now, with activity E, we've got to choose whether to move backwards from the 16 or the 15. When we're doing our backward scan, we always pick the lower of the two. So we're moving back from 15, 9 days, which lands us back at 6. And then we run into the same sort of problem for activity B. We're going to either be moving backwards from 9 weeks or 6 weeks. So we're going to move back from the 6 weeks. Taking 6 away from that lands us at 0. So we can see already that this is probably our critical path along here. But now we've got to do the top part of our graph as well. I'm just going to remove these little So 7 back from our 37 should give us a latest starting time of L at 30. Taking 11 away from that 30 should give us 19. Taking 7 away from that 30 should give us 23. From here, taking 5 away from our 19 should land us at 14. Taking 8 away from our 23 should land us at 15. And choosing between 14 and 15 for activity A, we're going to choose the 14 to work backwards from, which lands us at 1 there. So we can see that we've got a float time of 1 along this path up here. We've got a float time of 2 just in this little bit here. And we've got a critical path down here. We've got a float time of 1 running along this network here and a float time of 3 at F there. So now let's get into answering these questions. Question A says determine the earliest start time for activity K. So looking at K here, we can look at its earliest starting time there, 16. Now it's important that we include 16 weeks. So once again, including that unit there is important because it hasn't been described in the question. They haven't said, after how many weeks is the earliest starting time for activity K or something along those lines. So we need to make sure we include that unit in our answer. We're then told that the minimum completion time for the school is 37 weeks, which we found to be true when we did our forward and backwards scan. B says write down the critical path for this project. Now, of course, in order to find the critical path, we just need to look for the activities that have an earlier starting time and later starting time that are the same. So we're first looking at B, then E, then J, then M, then N. And that is our critical path. Activity C now asks us which activity has a float time of 3 weeks. Looking through all of these and comparing our earliest and latest starting time. So in order to find the float time, we should take the latest starting time and subtract the earliest starting time, or just look for the difference between the two numbers. You'll notice that activity F has an earliest starting time of 6 and a latest starting time of 9, and it is the only activity in this network that has a float time of 3. So which activity has a float time of 3 weeks? We could just say F. Cool. We're now given some more information. We're told that the completion times for activities A, D, E, G, H, and M can each be reduced by 1 week. The cost of reducing the completion time by 1 week for each of these activities is shown in the table below, and then we're given this table here. Question D asks us what is the minimum cost to complete the project in the shortest time possible. Awesome. So we can look at activities A, B, E, G, H, and M. So we've got A, where's B? We've got A, B, E, G, H, and M that we can reduce. So of course we want to start off by looking at whether we can decrease our critical path. So currently our critical path runs down B, up E, across J, and then down M, before finally continue at activity N. So the only thing worth minimizing to begin with is our critical path, or activities on our critical path. So the 3 activities that we have on our critical path currently that we could reduce are B, E, and M. Now M is going to cost us $13,000 to reduce, E is going to cost us $9,000 to reduce, and B is going to cost us $10,000 to reduce. So we would be tossing up between B and E to begin with, and the reason for that is also if we reduce B, that also has the effect of not changing any of the float times that come after it. So E, F, G, J, M, K, and N will all maintain their float times. Nothing will go down or take over. It'll reduce the overall completion time down to 36, and everything will drop by 1, which gets hard to track with actually writing down numbers, but I'll try and explain it as best that I can. So if we were to reduce, let's say that we go with the option E. So we're reducing E. Everything that comes after E would be reduced by 1 day, which means that the only difference between reducing E by 1 day and B by 1 day would be that F would lose 1 day of float time if we reduce E by 1 day, or if we crash E by 1 day, I should say. So let's start with adding in E. What would happen if we reduced E is that everything after it would keep its float times, so activities G and K still aren't on the critical path. However, this whole path here now takes 36 days, and everything that wasn't affected by E being reduced, that had a float time of 1, is now also on the critical path. So these guys along here are now they're all also on the critical path at this stage. So now what I want to look at is, can I reduce this any further? Can I reduce by another whole day? If I can reduce one activity that's on this critical path and another activity that's on this critical path, I can create another day of reductions. So if I were to reduce activity A on this top line, well, I've got the choice between activity A and activity H. I will start with activity A because it first of all it affects everything else that comes after it, so it won't change our float times, and it's also cheaper. So let's say I reduce activity A. In order to make sure that my crash along this line doesn't end up just making this other critical path the only critical path, I need to also reduce something from the other side. So in this case, I'm going to reduce B by 1 day as well, because it's my next best option. So at this stage, we should be down to 35 days in the minimum completion. Finally, I have activities G, H, and M that I could look at here. So I've got G and I've got H up here and activity M down here. So I could reduce these two activities by 1 more day. So let's say that I reduced activity H and activity M by 1 day. That would now land me at another minimum completion time. So reducing by another whole day. It's not worth us reducing G, because if we were to reduce G or crash G, we would just be leaving another critical path up here. However, if you are interested in how this is all working, it is sort of an acquired skill. I would suggest making a few templates of this directed network and then seeing what happens as you change one activity at a time, and seeing how that affects where the forward and how the forward and backward scan looks. So looking at the earliest starting times and the latest starting times, and comparing them to one another, because once you get a head around it, it becomes a lot more apparent, but it's quite a tricky concept to pick up if you aren't willing to put in the time to experiment with it. So the activities that we ended up reducing were A, B, E, H, and M, which if you take the values that are associated with reducing each of those activities by 1 day, you end up getting an answer of $46,000. Once again, including that dollar sign there is important. Writing down 46,000 isn't good enough, because we're asked what the minimum cost is, and it's not implied that we're looking at dollars. Or maybe it is implied, but it's not specified that we're looking for an answer in dollars, so it's important to include that dollar symbol in your answer to part D. Part E says the construction company is contracted into building another school, with one slight difference. The new activity O will take 1 week to complete and has a float time of 1 week. Part I asks for us to add activity O to the network below. So what we know about activity O is that it must be completed by the 15th week, so it needs to end week 15. And it has a duration of 1 day and a float time of 1 day also, which tells us that it's actually going to start on week 13, because if it could start, or if its earliest starting time was week 13, that gives us 1 day in between 13 and 15 to actually complete the task, and a 1 day float time somewhere, either that first day or the second day out of the 2 that we have available to us. So we know that activity O is going to start at week 13, which means the only place that it can start is after A, and it's going to end on week 15. And the only place that could connect to making at week 15, and it has to end on week 15, is down at this vertex here, which takes 15 days to get to. So I'm going to remove the earliest starting time and latest starting time for D, and activity O on your graph should travel straight between those 2 vertices, and we can put it in like so. Part II now asks us, what is the latest start time for activity O? So of course, we kind of explained this in figuring out where O was going in the first place. However, we know that O is going to have an earliest starting time of 13, and taking our 1 away from the 15, we're choosing out 15 and 16. Of course, we choose 15 for latest starting time. Taking 1 away from that, we get 14, meaning that our answer is 14 weeks. Once again, important to include that weeks, because we haven't had the unit specified. Excellent. So this is question FM298. Pretty complicated, so if you guys have any questions for us, please drop them in the comments below. Otherwise, I'll see you in the next video.